Hey, what's up, guys? Today we're going to continue in our unit functions, all right? And so we're going to spend a little bit of time just giving you some definitions. I mentioned last time there was a lot of language in this unit that is maybe not familiar or not language that you use every day. And so I want to define and remind us of some of that language to begin. And so last time we talked about a relation. A relation is any relationship between two quantities, all right? And so there is some connection, some relationship between these two quantities. And in order for a relation to be a function, we said that a specific relationship between two quantities where every input has exactly one output, okay? And so what we said last time, and this was the big point that we made in the first lesson, is that for every x, there could only be one y. In other words, another way we said it is that the x's could not repeat. So they couldn't repeat on the table, they couldn't repeat in the map, they couldn't repeat in the ordered pair, they couldn't repeat on the graph, okay? And so that's what makes it a function. For every x, there's one y. In other words, the x's cannot repeat, okay? And usually this follows some type of a rule or a pattern. And so today, we're going to actually be talking about how do I figure out what is the pattern? What is that relationship between these two numbers? Well, that's what we're going to be looking at today. But I want to continue by giving you a little bit of vocabulary from last time and then expanding on that a little bit. And so last time we talked about the input. So we had all of these x values and we said that that is the input. The input is the x values. Or another way to say that is the domain. Okay, so input can be called the x values, or it can be referred to as the domain, or it also could be sometimes referred to as the independent variable. Okay, now what I want you to hear is there are several different terms that you can use when describing the input. And so one way you can remember that is by this term Dixie. And then I'm going to get ahead a little bit. The other one that usually goes with it is Dixie-Royd. So Dixie-Royd is a way of remembering those terms. The D stands for domain. The I stands for input. The X stands for the X values. The I also stands for the independent variable, okay? So those are all the terms for input. Well, what are the terms for output? Well, it is also known as the Y values or the range. And it also can be referred to as the dependent variable, okay? So, again, hopefully you see where Dixie-Royd comes to help. Again, Dixie, and then Royd, the R stands for range, the O stands for output, the Y stands for Y value, the D stands for dependent, okay? So that is going to be super important that you can understand that for each of these, there's just different ways to refer to the very same thing, okay? So let's move on. The last term that I'm going to share today is solution. So solutions to a function is when you just put those two together, the domain and the range. Okay, actually, hold on, I did skip a part of the output. So the output of a function depends on what the input is. So that's going to be important for when we talk about the independent, dependent variable. We're going to talk about that more at the end of this unit. Okay, so the solution is, again, when we put the output and the input together, okay? And so given as a coordinate pair or an ordered pair, right? So when we put the x and the y together, again, we did this last time, but when we have the x and the y, those are the solutions to our functions, okay? So this is some important vocabulary. We're going to be spending a little bit of time going through this vocabulary. This is going to be important that we can keep all of this language together because it's going to really, really help us toward the end of this unit. All right. Now, so here is the rest of the lesson, we're going to look at function tables, okay? And so what this function table does is it shows the rule or the pattern. It helps us get to the pattern, but that connects the x values and the y values together. So for this particular problem, we have y equals 2x plus 3. And so it gives us this list of inputs. So we have them to the left side. And all we're going to do is we're going to take the 3 and guess what, or I'm sorry, take the x's and guess what we're going to do to the equation that it gives me? We're going to put them in, right? So we're going to insert each of the x's into our equation. We're going to substitute it in, right? And that should be familiar. And here we can use Desmos to help us calculate this. We'll just need to put 2 parentheses, -3 plus 3, and Desmos will give us our output, our answer. So 2 times -3 is -6, and then -6 plus 3 is going to be -3. 2 times -2 is -4. -4 plus 3 is -1. 2 times -1 plus 3 is going to give us +1. 2 times 0 plus 3 is going to give us 3. Oh, sorry. Yeah, it is going to give us 3. 2 times 1 is 2. Plus 3 is going to give me 5. 2 times 2 is 4. 4 plus 3 is 7. 2 times 3 is 6. And 6 plus 3 is 9. And so now we've taken our inputs and determined what our corresponding outputs are. And so now, in order to determine the solutions for each, we're just going to take the input and the output and put them together as a coordinate plane. Okay, so we got -3, -3. We got -2 and -1. We got -1 and 1. We got 0 and 3. We got 1 and 5. Then we have 2 and 7. And then 3 and 9. So those are our solutions. Now, are there any more possible solutions for these? Well, it only gave us these numbers, but really we could throw in any number and we can figure out what the output is. And so the answer to that question is yes, there's an infinite number of outputs that we could get. We could just plug in any number and then get what the output is. And so what I want you to do is, in just a moment, you're going to practice this, but what I want us to see is this. I want us to find the relationship for or in other words, the pattern for these numbers. Okay, so let's just look. When x increases by 1, so each x is going up by 1, all right? So this is +1, +1, +1, +1, +1, +1, +1. So each time we go up by 1, what is happening to our y's? Well, our y's are increasing. It might be a little hard for you to see with the negatives, but we go from 1 to 3 to 5 to 7 to 9. So what's happening? Anytime we increase the x by 1, we're also increasing the y by 2. Okay, so that is the pattern, or that is the relationship between these numbers. Okay, and so the rule is y equals 2x plus 3, and the pattern for what's happening to our outputs is that as x increases by 1, y increases by 2. So next we have 4 examples that you're going to do in just a moment. I'm going to do the first one, and then I want you to do the remainder of them. And so in this first one, you have y equals 5x. So for each of these, you're going to take the x's, and you're just going to plug it in for x. In this case, we're going to just be multiplying by 5. So y equals 5x. So we're going to say 0 times 5 is 0. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. So our solution is 0, 0, 1, 5, 2, 10, and then 3, 15. And now we got to figure out what's the relationship, what's the pattern. So as our x, it goes from 0, 1, 2, 3. So our x's are increasing. As x increases by 1, what happens to our y's? Our y's also increase, but they increase by 0, 5, 10, 15. They increase by 5. So what I want you to do for the remainder of your time is I want you to do number 2, number 3, and number 4. Do those examples. If you have any questions, raise your hand. I'd love to help you, but I do want you to attempt to solve them first before you ask any questions using this example here and the previous example. Good luck.